Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Today we are going to learn a new topic which is Psychrometrics. Not Psychometrics, different. This one is Psychrometrics. Okay, don't get confused, two different things. Okay, so what is a Psychrometrics? So psychrometrics involves determination of thermodynamic properties of gas-vapor mixture. The most common applications are associated with the air-water vapor system. So in this lecture, we are going to learn about the relative humidity. I think everyone already heard about relative humidity lah. Okay, that is one of the property that we have here in our surrounding here. Okay, relative humidity. We are going to learn how to calculate or measure the humidity ratio, how to find the dew point temperature, wet bulb temperature, dry bulb temperature, and so on. Okay, so in this lecture here, we are going to be focusing on the air, okay, that we have here lah. So inside our air here, actually, our air here is a mixture of air, okay, totally gas, gas and also water vapor. This one. Okay. So today's topic, we are going to be focusing on these two here. Okay, the temperature of these two here, which is the temperature of the dry bulb, dry bulb temperature, and also wet bulb temperature. So what is dry bulb? What is wet bulb? Okay, I will explain it in this lecture video. Before that, let's look at the properties of our dry air. So as you can see here, the composition of air, so we have most of it is nitrogen, 78%, oxygen, argon, carbon dioxide, neon, helium, and others. Okay, so this is the one that is gas. Okay, actually inside our air also we have water vapor. Water vapor. Okay, so this is the properties of dry air. It has a molecular weight of 28.9654 and the gas constant R here is 287.055. The specific volume can be calculated using this one, ideal gas equation. And the specific heat of a dry air, the average, okay, is 1.005. Why we say average? Because the specific heat can be differ or is different based on the temperature of the air. Okay, and then to calculate the enthalpy of this dry air here is equals to 1.005 multiplied with TA minus TO. TA here is the dry air temperature, TO here is the reference temperature. Okay, as you can see here, we label the dry air as A here. Okay, this one, small a. Small a, small a. Okay, so if you find in this lecture, small a, that one represents dry air. Okay, let's look at the properties of water vapor. Okay, one of the thing that we also have here in the air. Okay, the molecular weight is different, 18. Why 18? Because water lah. Water is H2O, H is 2, oxygen is 16. So we have H2O, so it becomes 18 lah, 16 plus 2. And then the gas constant is 461.52. Totally different than the dry air. Okay, the gas there. And the specific volume is this one. Okay. And the specific heat also different, which is 1.88. And the enthalpy is this one. Different, slightly different than the dry air. Okay. So as mentioned before, dry air we use the subscript A to describe dry air. So in water vapor here, we use small w. Okay, if you see small w, so that is the one that is representing the water vapor. Okay, now I mentioned many times about dry bulb temperature, wet bulb temperature. So how to measure the dry bulb and also wet bulb temperature? Okay, as you can see here, okay, this picture here, actually it is a video. After this I will play this video and we will look at it together. So this one here we call it as a psychrometer or hygrometer, either one. Okay, so this is the one that we use to measure dry bulb and also wet bulb. Okay, let's look at this hygrometer here. Okay, inside here we have thermometer. Okay, this one is also a thermometer. So what is the difference between these two here? So this one here, this thermometer here is exposed to the environment. This one and this one here, okay, this thermometer here, okay, the tip of this thermometer here, the part that we measure the temperature, it is covered by a cloth. To make it specific, it is covered by a wet cloth. Okay, so this is the difference how to measure it, because to measure the dry bulb temperature, we just release this thermometer here to the environment. Okay, but when we want to measure the wet bulb temperature here, we need to make our measurement area here to be 100% of water vapor. So how to create that situation is by using this wet cloth here. Okay, when we cover the tip of this thermometer here, okay, the water inside it will be evaporated. Okay, and it will create the condition where the relative humidity is 100%. So means that all of the water surrounding the tip of this thermometer here is the water vapor. Okay, so this is the condition that we want to create. So how we use this hygrometer here or the psychrometer here? So let's take a look at this video together. Okay.
This is called as psychrometer, which is used for measuring the wet bulb and dry bulb temperature. The dry bulb temperature is indicated here and the wet bulb temperature is indicated here. First of all, for taking the both of these temperatures, we need to add some water in this small jug.
Okay, as you can see here, this person here is pouring the water inside this area here. So this is actually the cloth, okay, that is connected up until this thermometer here. So when he added this water here, so this cloth here will absorb this water and will cover the tip of this thermometer here with a wet cloth lah. Okay, so this is how we create the relative humidity 100%. Okay, means that all of the water is evaporated, okay, at the tip of this thermometer.
To get the wet cloth, it will get soaked by this cloth also, so that it will absorb moisture and will get the wet bulb temperature. After that, swing the psychrometer in the air for about 1 minute.
Okay, so as you can see here, this is the way to measure. Okay, you need to swing it. Okay, so as mentioned in the video, he said around 1 minute. So 30 seconds 30 seconds to 1 minute is okay. Okay, so let's look at the result.
After 1 minute, we stop swinging and we'll get the dry bulb temperature, which is showing around.
Okay, so as you can see here, this is the reading. So this one is 10 degree, 20 degree, 30 degree. Wow, 35, 36, 37. So now in India, so at this day here is 37 degrees Celsius. Okay, so this is the dry bulb temperature.
37 and the wet bulb temperature is.
Okay, so this is the wet bulb temperature. Dry bulb we know 37, and for wet bulb here, if you can see here, so our measure is around this. Okay, so around 20 degrees Celsius. So dry bulb is 37, wet bulb is 20 degrees Celsius. So 70 degrees Celsius of different. Okay, so this is how we can measure the dry bulb and also the wet bulb temperature. Why we need to measure this one? So because we will use these two measurements here, dry bulb and also wet bulb temperature, to calculate or measure other psychrometrics, which is relative humidity, humidity ratio, dew point temperature, and so on. Okay, so this is why it is important for us to know at least two properties. Okay, so dry bulb and also wet bulb temperature. Okay, so that's all for today. Hopefully you can understand how to measure the dry bulb and also wet bulb temperature. See you again in the next lecture video. Bye bye.